that again. Slope 8-6. You all right over there? Okay. Slope is the steepness of a line measured by the change in the y values and the change in the x values. So if we wanted to measure what the slope was, we'd find the difference in the y coordinates and difference in the x coordinates. So I have printed off this this for you so that we can stay consistent and see exactly what we're doing, and also we don't have to worry about you guys making lines that are different sizes. Okay? So let's look at slope. We have difference in y and difference in x. If you wanted to make that an even smaller representation, you would say m equals delta y over delta x. Delta is change in. It's the military code for when something starts with a D. Did you write that? Do that. Write that down. Delta y over delta x.
So the triangle is delta.
So if we wanted to, yes. So it's the change. So the change in y or the change in x. So if we wanted to measure, oops. Come on, Scooter. There we go. If we wanted to measure what the slope is, first thing we would have to do is we would have to find a place where our line intercepts, where it's we can definitely see it go through something on the domain and something on the range. Now I tried to do this as best I can, but it looks like we might have it be a good connection right here at 1, 2, 3, 4, 5, and 1. So we have 5x. 1, 2, 3, 4, 5. Okay, 5 and 5. I want to make that thinner. Let that be more accurate. Does that work like that? Hey, there we go. So it looks like 5 and 5. And then the next spot that it actually is going to be intercepting perfectly, if I'm looking through this, looks like we have looks like we have this point here, which is going to be 0, 1. 0, 1. Now I want to find my slope for this guy. So I'm going to do slope. Now the change is going to be where something was, but it moved to another place. So if you had a change in money in your wallet, it would be a certain amount, and it's either going to be more or less. How would we find how much money we won or lost? How much money did we find or lose? What would we do that? What mathematical operation would that be? Subtraction. If we wanted to find out what the difference was, right? Difference, isn't that the answer to a subtraction problem? Okay. It's the difference. So I have m. I'll move that up so those sitting in the back can see. So what was my change in y? I went from where to where? Yes. Where there's an intersection. You know how that would be like a map? It's where those two match. And for this one, if I zoomed in a bunch. Yeah, see how this misses this intersection? And this one definitely, it's missing that one. It's really close to this one, but it's actually... Ooh. But it actually came super close to that one, I guess. Is there? So should we choose a better point? Ooh, look at these. Look at this. Thank you. And it even shows even better on yours as well, even though yours is thicker. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8. Nine and then 8. What? No, I did that one because you said it was a better match. I could have kept the 5, 5 there, but that might not be as accurate as this one. It was a better match. It was a better match in this situation. So I have to find the difference between those two. To find the difference, I'm going to go from left to right. Okay, I'm going to go from left to right, and I'm going to write down the coordinates of my y values. Okay, of my y values. So I'm going to have m. I have this written below. You can do it below or on the graph itself, whatever you'd like. My change in y over change in x. Come on. Thank you. Oh, see, that's what happens when I don't have it really big. See how wobbly it got? I start for change in y. I go from 1 minus, then I have my 8. 1 minus 8 over what? Garrison. 0 minus 9. So I'm going to go down here so you can see it better. So I have negative 8 over negative 9, and is that its simplest form?
Yes.
Negative 7? What did I do? Oh, 1 minus 8. My goodness. A negative divided by a negative is a positive. Yep. So it comes out to be 7/9. So the slope of that guy equals 7/9. So the slope of that line, that is how steep that line is. Yes, sir? Because a negative divided by a negative is a positive. A negative divided by a negative is a positive. Yes, sir? No, it won't be as accurate because this one had a better one. I mean, if you wanted to, so you would have negative 4, you would have 4/5. 4/5, but 8/9 is a more accurate number because it's really close to 1, but it's not close, but it isn't 1. Yes? Hold that question. We'll find out in a minute. Yes?
So that line is 77% in a way, and then like 100% we're back to like straight up and down. Like,
Those are wonderful, wonderful questions, and I've anticipated them both. And the next 3 graphs will answer those questions, okay? So now we have another line here, okay? Now we have another line, and we are going to be going through, it looks like I tried to do that one there. And it's very similar to what we just had. And I'm going to move this. I wonder if I can move this.
there's one right up there. Yeah, right up there.
That one? Should we try that?
Yeah.
So that one looks like it's going to be pretty close too? Okay. The reason why it's not snapping perfectly on there is because it's not Photoshop, it's Microsoft, so it's not going to be having that many. So I'm going to go to this spot here. Okay, I like to read left to right, so I'm just going to read left to right again. This point here is going to be 1, 2, 3, 4, 5, negative 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 5 and 8. This guy here is 0 and 1. 0 and 1. So I'm going to do my delta y over delta x again. You don't have to rewrite that. I'm just doing it for memorization reasons. Change in y over change in x. So I'm going to do my y is going to be 8 minus 1 over negative 5 minus 0. Negative 7/5, which equals negative 1 and 2/5. That's an ugly looking 1 and 2/5. Let's try that again. It wasn't, it was, you know, the 2 was like, yeah, it's going to look like this. We have to find slope. You have to find slope or create slope. Okay, so now this one here, we have a slope that is negative. Now we have a slope that is negative, and we have a slope that is positive. Now what do you notice about these two different lines? Let's get somebody I haven't heard from today. What do you notice about them? Yes. They're going different directions, exactly, because this one's going, well, how would you describe the direction of the one on the left? Okay, so you're saying to up and to the right? Okay, yes. It's positive and it's going up and to the right. Very good. Now we have this guy, which is negative, and it's doing what?
Up and to the left.
Is it going up? Okay, up and to the left. What if we were saying to the right? Down and to the right. So a negative slope. A negative slope, if we are reading, okay? Okay. I don't know if you guys did this because you guys all had technology you could be staring at instead of looking out the window over long rides to northern Wisconsin. Did you guys ever have the little guy that runs on top of all the trees and everything that, okay? It's his hair, okay? Maybe someone just running across the horizon as they're going. Okay, you know how we read to the left or from left to right? So if you are having that guy or you're in a car and you are driving like this, are you driving uphill or downhill? Okay, you're driving right to left to right like we read, you're driving uphill on a positive incline. If we are reading, you are gonna really, come on. I'm not even close to that line. There. But now if I was going this way, I'd be going downhill, right? So when the slope is negative, the higher that x gets, the lower that y gets. Okay? When it's positive, the higher the x gets, the higher the y gets. What's that called from last week? Positive, yes. A positive relationship. So a positive slope, yes. Positive slope, positive relationship. Beautiful. You guys are catching on very well. Now let's explore the extreme. Okay? Yes? What are you talking about, sir? We can use any two spots. We can use any two spots, and we're going to find something very similar to that slope. It's not going to be perfect because I did these myself, drawing, okay? So it's not going to be perfect. But if we had a actual line that was perfectly thin that only matched one point, so I'm going to go from, I'll go from this point here, which is, oops. this point here. See how accurate this is going to be. Yeah, see where I'm at? Oh, there we go. This slope will be -1. That slope's going to be -1. Let's test it. This is how it's going to be. So it goes from this point, this point, this point, this point, all that. Go ahead and measure any of these points that you see on here. For example, if you're curious as to how this is going to work, how would I know? Oop, 8. Come on, please erase. Thank you. That's 8, -8. This down here is going to be 100 and -100. This one here would be -100, 100. Okay, way up there. It's going to be -1. Your slope is going to be -1 because that one looks perfect. So that's a slope of -1. Let's talk about what it looks like when we have a similar situation, but it is a sleepy line. It is a sleepy line. Sometimes it depends. There, I made it thinner. So we have a sleepy line here. I'm going to draw this point here. I have 1, 2, 3, 4, 5, 6, 7, 8. This point here is going to be 8 and 1. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10, -1. Find the slope from those 2 points. Find the slope from those 2 points. I'm going to find the slope from these 2 points. It means make a difference of those 2 numbers. Subtraction difference. Do you guys get 1/8? Okay, sorry. It also goes through here. I did a different plot point on purpose. I did that on purpose. There's a reason for it. Let's see how close mathematically accurate this is. Oops. Okay. So you guys would have got 1/9. I got 1/8, but it's not going to be perfect because, like I said, this isn't this isn't a mathematical program to make this. This is a presentation program made from Microsoft. So we are close. Okay. Do you agree that this number is pretty small? 1/9 and 1/8, right? Relatively speaking, small. Obviously, you guys know that we can get a lot smaller than that, but I got 1/8, you got 1/9. Now let's look at this one. Look at the slope of this guy. We can do this one together. I'm going to take 0, 0, and maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm just picking a spot that could be on there. 1, -12. So let's find the slope of this guy. Change in y over change in x. I start at 0, and then I get to -12. Start at 0, then I get to 1. I got m equals negative 12, and you should have as well. Notice how this guy, which is lying down, it's a very gradual steepness. It's a very gradual steepness, and look how small the number is. It's 1/8. Yes, it's 1/8. Look how gradual it is. It's a small number. Look how steep this one is, and look how big of a number it is. Negative 12. That's why I want to show you that. So a vertical line, which is not a function. I've lost you all. A vertical line.